Hello everyone, this is Mr. Underkoffler, and today we're going to be looking at a short little guided notes called Exponents, When to Use Parentheses. And you might recognize this because this is something I did initially teach you early in the beginning of the school year, but it's a very necessary review because of this new unit we're about to get into, which is all about exponents and also square and cube roots. So there are some things I need to review with you, and so that's the purpose of these guided notes. So before I get started and start reading to you the main ideas at the top of the page, I do want to talk about some basic vocabulary here. When I talk about the base, for example, here we have negative 8n to the third power. The negative 8n, which is the thing that is taken to a power, that is what we call the base. And then the exponent is whatever power we're taking it to. So just real quick review there on the vocabulary. All right, so the major rule that I need to teach you today is any time that you have exponents and your base happens to be a negative number, a fraction or mixed number, or some kind of algebraic expression like I had here, negative 8n, anytime your base is one of those three things, then you must put the base in parentheses, and then the exponent will be outside of the parentheses. Now, you might be like, well, why does that matter? Because if you don't have the parentheses around the base, when your base is a negative number, a fraction or mixed number, or an algebraic expression, if you don't have parentheses around the base, then it won't be what you want to take to the power. Now, what do I mean by that? Well, for example, problem number 1, it says write the following using exponents. That's what the directions say. And here we have negative 7 times negative 7 times negative 7 times negative 7. You can see there's 4 of them. If I don't put the negative 7 in parentheses when I take it to the fourth power and put the fourth power outside of the parentheses, then without the parentheses, only the 7 will be taken to the fourth power instead of the entire base of negative 7. I'll give you another example. Problem number 2, 2/5 times 2/5 times 2/5. I must put the 2/5 in parentheses and then put the power of 3 outside of the parentheses, because without the parentheses, if I would not have the parentheses there, then only the numerator of 2 would be shown taken to the third power. So to mathematically show that the entire fraction of 2/5 is taken to the third power, I would have to put the fraction in parentheses and then put the third power on the outside. Same thing with problem number 3. A plus 4 times a plus 4. If I don't put parentheses around the a plus 4, then only the 4 would look like it is taken to the second power. So to show that the entire algebraic expression of a plus 4 is taken to the second power, I must put that algebraic expression in parentheses with the power of 2 on the outside. That's why the top of your page says, anytime you have exponents and your base is a negative number, a fraction or mixed number, or an algebraic expression, then you must put the base in parentheses with the exponent written on the outside of the parentheses. And hopefully you can see what I'm talking about here on examples 1, 2, and 3. All right, problems 4, 5, and 6. I want you to try them on your own. Again, the directions are only asking you to write each of the problems using exponents. So there's nothing you have to solve per se. You're just going to write it using exponents like the directions say. So hit pause in the video, do numbers 4, 5, and 6 on your own, and then hit play when you're ready to see how you did. All right, I hope you've already hit pause and have done 4 and 5 on your own, and 6. Here we go, let's see how you did. Problem number 4, did you write the negative 1/2 in parentheses and then put the power of 5 on the outside? Now, where you put the negative sign is kind of actually up to you. I like to keep my negative signs on the numerator, but you could actually put it in front of the fraction bar, and that would actually mean the same thing. Technically, you could put it on the denominator, but that's not as normal. So normally I would not recommend that. But you do have some options there as to where you put the negative, but it must be in the parentheses with the 1/2. Problem number 5. We have 8 of these negative 3's being multiplied to each other, so you must put negative 3 in parentheses and the power of 8 on the outside. Problem number 6, we have 3 of these algebraic expressions of 2x plus y's being multiplied to each other. So once again, you must put the 2x plus y in parentheses and the power of 3 on the outside. All right, so I have a little note just in case you're not believing me that negative numbers to a power would not mean the same thing if you do not put the negative number in parentheses. I put a little compare and contrast here to show you why the parentheses actually do matter, especially when it's taken to an even exponent. Odd exponents, it actually would give you the same answer either way. Let me show you what I mean. When you have -7 written in parentheses and the power of 4 written on the outside, then what that means is that the entire negative number of -7 is being multiplied to itself 4 times. So you would have -7 times -7 times -7 times -7. And then -7 times -7 is +49, times another -7 gives you -243, times another -7 gives you a +2,401. Now you don't need the positive symbol there. I'm just trying to make a point to you that a negative times a negative, remind you, is a positive. Well, what happens if I don't have the parentheses around the -7? Well, then what it means is that only the 7 is being taken to the 4th power. Believe it or not, with order of operations, the negative would be dealt with last if it's not in parentheses with the 7. So what that means is you would take 7 to the 4th power first and then make the answer negative at the end. So that would end up giving you 2,401, and then the negative stays to the left of that answer. So basically, the negative sign would just be brought down onto the final answer because it happens last according to order of operations. So this is why I taught you at the top of the page. If you want to show that a negative number, the full negative number, the entire negative number, is being taken to a power, then you have to write the negative number in parentheses with the exponent written on the outside. The same is true if your base is a fraction. The same is true as if your base is an algebraic expression. All right, moving on. Problem number 7. Which of the following does not need parentheses written around the base? Hit pause in the video, choose whether it's A, B, C, or D, and then also explain why. That is the second piece of this problem. Please do that as well. So try this on your own. Hit pause in the video, then hit play when you're ready to see how you did. All right, I hope you've already done number 7 on your own. So when do we need parentheses? Well, it's when our base is a negative number, a fraction, a mixed number, or an algebraic expression. So which one of these choices is not one of those 3 things where you must have parentheses? Well, it would be choice B. And it's because if your base is just a whole number, then that is not one of the things that we talked about at the top of the page where you would have to put it in parentheses. Whole numbers do not need to be put in parentheses when they are taken to a power. So that's your explanation. The base was just a whole number here. Problem number 8. Explain why 4x plus y in parentheses taken to the second power is not the same as 4x plus y to the second. Go ahead and hit pause in the video. Explain this on your own, then hit play when you're ready to see how you did. All right, I hope you've already done number 8 on your own. Let's see what you said. Well, with 4x plus y in parentheses to the second power, the entire expression of 4x plus y is being taken to the second power. But when there are no parentheses, then only the y would actually be taken to the second power. This is why they're not the same when the one has parentheses and the other does not. All right, for the final section of these guided notes, we have a real quick review on order of operations. Remember, parentheses, also brackets, any expression in a fraction, those things must be done first. Exponents must be done second, then multiplication and division going left to right, and then finally addition and subtraction going left to right. And problem number 1, I believe, is already done for you, for those of you who have your guided notes printed out. The directions say that we're going to evaluate each expression, and if you already forgot what it means to evaluate an expression, it means find the final answer to that expression, but you're going to notice they give you values of the variables. They tell you h is 4, m is 5, 6, and W is -3. As always, we're going to show our work, and this is a no calculator section. So problem number 1 is already done for you if you have your guided notes printed out. So what do? The very first step is what we call substitution, where you replace each of the variables with the numbers that they happen to equal. Notice what I had to do with the W, since it was a negative number taken to a power. It's what we just learned at the top of the first page. If your base is a negative number or a fraction or an algebraic expression taken to a power, then you must put that base in parentheses. So that's what I did. These parentheses are not optional. If this was a test or a quiz and you would not put the parentheses around a negative number or a fraction or an algebraic expression that is taken to a power, then you would lose a half point or a whole point, depending on how I made the rubric for that grading. So make sure you have the parentheses in those situations. All right, so from here, order of operations. Parentheses would be done first. Well, there's nothing to do in the parentheses if there's only a number inside. So we now go to the exponents. -3 to the second power means -3 times -3. And a negative times a negative would be a positive. Something that you might have remembered from earlier this year when we talked about negative numbers with multiplication. If you have an even number of negative numbers multiplied to each other, you will get a positive. If you have an odd amount of negative numbers being multiplied to each other, so that would be odd exponents, then you will get a negative answer. So that's something I don't have typed up on these guided notes. Maybe I should have. Feel free to write that down if you want to remember it and you didn't already know that on your own. So if you have to rewind the video to hear me say that again, feel free to do that. All right, so finishing this off, we have multiplication. 4 times 9 is 36. All right, I want you to try 2, 3, and 4 on your own. So hit pause in the video, do all of the work for those 3 problems, and then hit play once you're done with them and you're ready to see how you did. All right, I hope you have already hit pause on the video and you have done numbers 2, 3, and 4 on your own. So let's see how you did. Very first step should be the substitution step. Did you remember to put parentheses around the 5, 6 and put the exponent of 2 on the outside? The 4 is not in the parentheses. When you have 4 times m to the second, only the m to the second is being taken to the second power, unless there would have been parentheses on the original problem around the 4m, but that was not the way that number 2 was written. So only the m is taken to the second power on this problem. All right, 5, 6 to the second power means not 5, 6 times 2. It means 5, 6 times itself. So that's 5 times 5 and 6 times 6, which would be 25 over 36. And then what you can do is this trick that we learned about multiplication of fractions from earlier this school year, that if there is a numerator and a denominator, even if they're diagonal from each other, that are divisible by a common factor, then you can reduce before you multiply, and that's exactly what I'm doing here. The 4 and the 36 are both divisible by 4. Now notice I wrote the whole number of 4 as a fraction by putting it over 1, so I can multiply it to 25/36. All right, so 4 and 36 are both divisible by 4. If I reduce diagonally, I would get 1 and 9. 4 divided by 4 is 1. 36 divided by 4 is 9. And then this is really simple multiplication. This would give you 25/9, which as a mixed number is 2 and 7/9. If you did not reduce first, then you would get 100 over 36. Now, you could still reduce from there. You could still reduce the numerator of 100 and the denominator of 36, both by 4, or both by 2, and then both by 2 again, and you should still be able to get the same answer that I got here on problem number 2. All right, problem number 3. Substitution should be done first. -3 times 4 to the second. The 4 did not need to be put in parentheses because it is a whole number being taken to the second power. But when w is -3 and that is taken to the 4th power, that's where you must have parentheses around the -3 when it is taken to the 4th power. All right, from here, there is nothing you can do with the parentheses with -3 inside. So the next thing to do is the exponents. 4 to the second, it means 4 times 4, which is 16. -3 to the fourth power means -3 times -3 times -3 times -3. 3 times 3 is 9, times 3 is 27, times 3 again is 81. As I told you a few minutes ago in this video, if you have an even amount of negative numbers multiplied to each other, then you will get a positive. So that is a positive 81. If it was an odd exponent, then a negative number to an odd exponent would give you a negative answer. All right, from here, order of operations, you would multiply before you add. So -3 times 16 is -48. And then finally, -48 plus 81. Whenever you have a negative plus a positive, you will subtract in your head, and that's going to give you the answer of 33. Finally, problem number 4, substitution. The 5, 6 did not need to be put in its own unique set of parentheses because it was not taken to a power. Notice the exponent of 2 was on the outside of the parentheses, so it must stay there when you substitute it in the next step. Make sure that is outside of the parentheses. That is very important because according to order of operations, you must do everything that is in parentheses first. So the 6 times 5, 6, the 3 times 4, and then the subtraction problem that you will do a step later. All those things in the parentheses must be done before you deal with the exponent of 2, which is sitting outside of the parentheses. So here we go. 6 times 5, 6 would be 6 over 1 times 5, 6. You could reduce diagonally, and that would just give you 5. Now, you also could do 6 times 5, which is 30, divided by 6, would also give you 5. There is a cool shortcut trick. If you ever have a whole number multiplied to a fraction, and the fraction has a denominator that is the exact same number as that whole number, or maybe that whole number is divisible by that denominator, like if it was 6 and 3, 6 is divisible by 3, then a shortcut is you can divide the whole number by the denominator and then multiply that answer times the numerator. 6 divided by 6 is 1, times 5 is still 5. If you need to hear me say that again, feel free to rewind the video to hear what I just explained as a shortcut for that part I highlighted in green. 3 times 4 is 12. Now notice, this is still in parentheses. Why? Because I haven't done everything inside yet. I still have to do subtraction. So I hope you had the parentheses still around the 5 minus 12 and the exponent of 2 on the outside, because you're not done with the parentheses yet at this moment. 5 minus 12 is -7. That is going to now be taken to the second power. -7 times -7 is 49. Now you might be like Mr. Underkoffler. Why are you not making the subtraction become adding the opposite? The reason why I am not is because the negative is in parentheses and that negative number is being taken to a power. Order of operations says you have to do exponents before you do the subtraction. This is why I am not making that subtraction become adding the opposite yet, because if I did, I would be breaking order of operations. You must do exponents before you do subtraction. So if you made that mistake, maybe write yourself a little note off to the side that you have to make sure you do exponents before you do subtraction. Okay, where was I? -7 to the second power is -7 times -7, which is positive 49. 14 minus 49. If you now wanted to make the subtraction become adding the opposite, you could. You can make this plus a negative. Now, maybe you don't need to. Maybe you already remember that when you have a smaller positive minus a bigger positive, you will get a negative answer. So I'll kind of leave it up to you. If you want to make the subtraction adding the opposite there, make it plus negative, you could. Maybe, though, you don't need to. Maybe you remember a smaller positive minus a bigger positive would give you a negative result. All right, so there you go. that is the end of the guided notes called Exponents When to Use Parentheses. I hope you use the rewind feature. If there was anything that you heard me explain that you wanted to write a little note to yourself, so that way you don't make certain mistakes again in the future, hopefully you use the rewind ability of the video. All right, thank you for watching. We'll see you next time.